Okay, we're going to take a look at this desmos little applet on gradient functions. So we've got a parabola that's been drawn, x squared plus 6x plus 8. We're going to draw a tangent initially at the point of negative 8 and 24. Now remember what this means. This means that if we could find the gradient of that tangent at that point, then we have basically what the rate of change is at that moment of time on the curve. And remember, we can do this with our graphing calculator. If we draw the graph and then we then go to sketch tangent, and we say we want the tangent sketched at negative 8, then it will sketch we'll get the same picture basically as we have on desmos with an equation of negative 10x minus 56. Negative 10x minus 56. So that's the equation of the gradient, the tangent to that at that point. Now you look down here, there's a point that says negative 8 and negative 10. That negative 10 is actually the reflection of that gradient on that tangent line. And the gradient is negative, and it's negative 10 in this case. And so the actual gradient function starts to be drawn from this position here. And as we move our tangents and keep redrawing and redrawing and redrawing tangent lines to the curve, you'll see that the gradient is still negative. It's negative 8.2. and so on, and we keep moving it. It's still negative, negative 5.8, negative. So this is mimicking the gradient function, as if you will, as we go along and then we take the gradients of the tangent lines. And remember, it stays that way until we get to this point here where the gradient is now 0. So we have, if I click that, so we have the gradient function negative 3 and 0. So this is where the gradient of the tangent line becomes 0. Now if we continue on with this, look at what the gradient is. It's 1. It's positive, and it stays positive all the way through here. And positive, positive, positive. So if you go back to this, and starting back here, what I do is I'm going to plop up the actual gradient function for this particular parabola, and we see how it gets created. So if we start at our point at the original negative 8 and 24, and we start moving down along the curve, these gradients are all negative, so they're below the x-axis, becomes to this point of the turning point of the parabola where it's 0, and then after that starts to get positive. And you can see that purple line, that purple dot basically mimics the gradient function for this parabola. And that's how now you do not have to draw a straight line that is exactly that. You estimate it. Basically you need this point here, and you need the part of the graph basically to the left of this has to be below the x-axis, and to the right of this point has to be above the x-axis. And really the slope of it's not that significant. It's not that big a deal that you get a little bit wrong. As long as you have the basic principles of the gradient function and it reflects that, you'll be okay.